Welcome to the fifth episode of 5G Tech Talk. I want to thank you all for the great response to my previous episodes. Today, we are diving deep into the world of 5G network architecture. We will specifically explore the two main types of network architecture in 5G, the reference point system architecture and the service-based system architecture. We will also discuss key network functions like access and mobility management function, AMF, user pin function UPF, and session management function SMF. There are other network functions as well, but these will not be covered as part of this podcast. Here is the list: authentication server function, policy control function, and network slice selection function. So without wasting time, let's get started. I'm your host Modi Tehani and handing it over to my AI assistant Daniel. Thanks Daniel, and over to you.
Thank you, Modi, for providing me this great opportunity to serve. First, let's start with the basics. What is network architecture? It refers to the overall design and structure of a telecommunications network, including its components, connections, and how data flows through it. In the context of 5G, this architecture is more advanced than in previous generations, designed to support massive data traffic, ultra-low latency, and a vast number of connected devices. To start, let's talk about what network architecture actually is. In the simplest terms, network architecture refers to the layout or design of a telecommunications network, including all the components, connections, and protocols that allow it to function. Just like how the structure of a building ensures it can support its occupants, network architecture ensures that data flows smoothly and efficiently between users and services. In 5G, there are two primary types of network architecture: the reference point system architecture and the service-based system architecture. Let's break down what each of these means and how they work. The first type is the reference point system architecture, which is more traditional and similar to what was used in 4G LTE networks. In this architecture, network functions are interconnected through predefined reference points. Think of it like a road network where each intersection or reference point connects specific roads or network functions. In the reference point system architecture, every connection between network functions like AMF, UPF, and SMF is clearly defined. These reference points are used to establish communication paths for data and signaling. While this architecture is reliable and well understood, it's somewhat rigid, meaning it can be less flexible when adapting to new services or traffic demands. Now let's talk about the service-based system architecture, which represents a more modern and flexible approach to 5G network design. Imagine a highly efficient, automated warehouse where every robot or network function can communicate directly with any other robot as needed, without being restricted to predefined paths. This is the essence of service-based architecture. In this architecture, network functions like AMF, UPF, and SMF interact with each other through service-based interfaces, rather than fixed reference points. This means that each network function can offer its services to other functions as needed, making the network more adaptable and scalable. Now, when we talk about 5G network architecture, we're dealing with a system that's significantly more advanced than previous generations. It's designed to support the massive data traffic, ultra-low latency, and vast number of connected devices that 5G promises. Central to this architecture are the AMF, UPF, and SMF. But what exactly are these components, and what do they do? Let's explore each one. First up is the AMF, or Access and Mobility Management function. Imagine you're driving through a series of tunnels. As you move from one tunnel to another, you expect your GPS to stay connected and guide you smoothly without interruption. That's similar to what the AMF does in the 5G network. The AMF is responsible for managing user connections and mobility. When a device, like your smartphone, connects to the network, the AMF is the component that handles this initial connection. It's also in charge of maintaining the connection as the device moves from one location to another, ensuring that your service remains uninterrupted, whether you're making a call, streaming video, or using a GPS. In essence, the AMF acts as the traffic controller, managing the signaling and connection sessions that allow devices to communicate with the network efficiently. Next, we have the UPF, or user plane function. If AMF is the traffic controller, then UPF is like the highway system that transports your data. The UPF is responsible for forwarding data packets between the user's device and the internet or other network services. In simpler terms, the UPF is where the actual data traffic flows. It handles all the user data, whether it's a video you're streaming, a web page you're loading, or the messages you're sending. The UPF routes this data efficiently to ensure that it reaches its destination quickly and reliably. The UPF is also crucial for supporting the low latency that 5G promises, especially for services like real-time gaming, virtual reality, or autonomous driving, where even a slight delay can make a big difference. Finally, we have the SMF, or Session Management Function. Think of SMF as the network's coordinator or manager. It's responsible for establishing, modifying, and terminating sessions between the user's device and the network. Every time you start an activity that requires data, like starting a video call or downloading a file, the SMF sets up a session to handle that specific task. It ensures that the right resources are allocated, monitors the session, and adjusts things as needed to maintain the best possible quality of service. The SMF works closely with both the AMF and UPF to manage how data flows during a session, making sure everything runs smoothly from start to finish. Now you might be wondering, how do AMF, UPF, and SMF work together? Imagine you're on a high-speed train. The AMF is like the station master, ensuring you're connected to the right train. The UPF is the track system, guiding your journey, and the SMF is the train's conductor, managing your ride from start to finish. In the 5G network, these components work in harmony to manage connections, direct data traffic, and ensure seamless communication. Together, they make the 5G network robust, flexible, and capable of handling the demands of modern digital services. So there you have it. AMF, UPF, and SMF are key pillars of 5G network architecture, each playing a vital role in ensuring that our increasingly connected world functions smoothly and efficiently. Understanding these components helps us appreciate the complexity and power of the networks that keep us connected. That's all for today's episode of 5G Tech Talk. I hope you found this deep dive into 5G network architecture insightful. If you enjoyed this episode, be sure to subscribe and leave a review on your favorite podcast platform, and stay tuned for more discussions. Until next time, I'm Modi's AI assistant Daniel, signing off. Stay connected, stay informed.